In our question today, we've got a function given by this here, and we're trying to find the normal at x equals 0, showing that it is this result. So just a reminder, a tangent means when you have the same gradient, okay? So that's when you have the same. And a normal is perpendicular to the tangent. So this is the negative reciprocal, okay, for the gradient when it's at x equals 0. So I've done a little bit of the groundwork already. We can think of this as our inner function and this is our outer function, or we could set up our chain rule using the formal method, as I've sort of done here on the right. But I would encourage you to start getting a little bit quicker with it. So the inner function was here, and that was the derivative. The outer function is just e to the something, so it's just e, and then you just replace back in whatever was there. So let's write that down now. So we're going to write, let's do the way I would normally do it is I would normally have the inner part first and I would work outside. So this is the way I would normally have it written. So I have that multiplied by e differentiated is e, and you just fill in what was there before, okay? So you don't change it, you just write it back in exactly as it was. Okay, so that's our result there for dy dx. And now we're going to sub in at 0. So I'm just going to change my notation. I think it's slightly more convenient. So that's going to give me what? Well, let's just write our brackets here. So that's going to be a -3 times, effectively, sine 0 is 0. So I'm not going to get anything from that. Plus 2. So just keep track of that. 3 to the cos of, let's write this, 0 plus 2 lots of 0. So that's not going to give me anything. Cos 0 is 1. So I think overall I get 2 e 3 times 1. Okay, so I get that result there for my gradient. Well, that would be for the tangent. So for the negative reciprocal, it's going to be what? It's going to be -1 over that. There's lots of other ways you could write it, but that's the way that I'm going to go for. Okay, so this here, this is my m value. Yeah, that's my m value for my question. And in fact, that's why you can see that result there. So what to do next? Well, next, I need to think about what a y value would be. Okay, so if x equals 0, what does that give me for a y value? Because a point and the gradient will give me everything that I need. So I need to sub this into which equation? Well, do I want a gradient? Because if I want a gradient, it's this one. Well, no, because I already did that. What I want is I want a y value. So I want to use the original equation. So that's going to be y equals e to the 3. I'll just make it really clear because it does say show that. E to the 3, 0 plus 2 lots of 0, which is going to be equal to what? Well, that's going to be a 0 again. It's going to be a similar result to before, isn't it? So it's e cubed. Okay, so e cubed there. So now I have 0 and e cubed. And I have, for my m value, I have, what was it? -1 over 2 e to the cubed. So I'm going to use this information now. There's lots of ways you could do this. I'm going to use the y minus y1 sort of approach. So y minus y1 equals m, x minus x1. And then I'm going to substitute in some values. So I'm going to say, let's do y minus e cubed equals the gradient we had from before, which is -1 over 2e cubed, x minus 0. And, you know, it's not much of a leap from there to y equals -1 over 2e cubed, x, that's just expanding out, plus e cubed. Okay, so that was a question there where we were trying a couple things, but we had a little bit of chain rule over here. We were handling the normal carefully, and we made sure we wrote the whole sort of answer, you know, fairly clearly with the final result, which we're expected to get to as well, as it is a show that question.